Okay. Okay. Next question that we got on the menu today is how do we factor out x cubed plus 1? We gotta factor that little equation. Okay. I guess we can put brackets around it. Doesn't really matter. Now, this is one of those situations where we want to use the difference of cubes. So anytime you see where you're trying to factor out things and hey, it's two terms added together and both of them are cubes of something like x to the power of 3, that's clearly x cubed. 1, well, that's 1 cubed. You can pull something like this, the difference of cubes, and this will be a nice way to handle this. Okay, so just gonna verify something super fast. Okay, so difference of cube works for cubic things added together as well as subtracted from each other. So I'll actually write it like this. So suppose we have a squared, or no, not a squared, a cubed to the power of 3 plus minus b to the power of 3 plus minus, it can be added, it can be subtracted, it'll work either way. Okay, so if we have a cubed plus minus b cubed, we know that the result is going to be a plus minus b. Multiply that by a minus plus ab plus b squared. Okay, now this is always positive. These two will be same sign. And these two will be opposite sign. No, not Sam sign. Hey, Sam's my dad's name. So, yeah, nice. And that will be opposite sign. Okay, so we know that in this situation, x is equal to a and 1 is equal to b. Now if this was like plus 125, you would have to take the cube root of that first. So if it's 125, it would be b is equal to 5. Okay, or I mean that's just an example at 125, but there are other types of cubes that you can just take the cube root before you set 1 to a and before you set 1 to b. I'll actually write that in. So cube root. This is what a cube root looks like. Awesome. So let's expand this out. So we got x3 plus x to the power of 3 plus 1. So that is equal to a plus b. So because they're the same sign for this one and that one, they're the same sign, so it's going to be just x plus 1. X plus 1. And because we know that a and b are x and 1 respectively. And then the next thing, oh, this should be a squared. My bad. Yeah. You kind of see how that pattern forms, right? Now here in the second term, we want to have the first one squared, so x squared, or a squared. Now this is going to be opposite signs to what you see in here. Opposite signs. So what we're going to put in there instead of plus, we're going to put minus a times b. Well, what's x times 1? I think that's x. I know that's x. And plus b squared. 1 is b. 1 times 1, still 1. Okay, so b squared, that's 1. Now, could we factor this any further? Well, if we factor this, that means we'd have to find two numbers that multiply together that make 1 and add up to -1. I don't think we can do it. I don't think we can factor this out anymore. So this will be like the complete factorization of the problem, x cubed plus 1. So this is the key thing here that will really make your life easier is the difference of cubes equation. Keep that handy because when you see cubes, think of how you can possibly factor them out. Sounds good? Yep, and they came to precisely the same equation with precisely the same process of difference of cubes. There's also difference of squares. It's kind of a similar thing, but you know, that's a different topic for a different time. So the above solution is good.